So, the first chapter is sort of orientation of what we're going to do here. So, web applications are what you use mostly on the internet, like Gmail, Canvas, any product, Amazon, any site you go to these days is far more complicated than in the old days. There were sites that were like mine. Now, my site is a really old-fashioned site. People sometimes complain about how primitive my site is. This is the way the web was in like 1998. You would just put a file up here. There's one file called index.php, which is this page. And when you click the class, you go to another page. And this is a literal page ending in SHTML in a folder named 129s. This was the original web. You just had files and folders, and a web server was really just essentially a file server. All it was going to do was download the file to your browser as you surfed around, and the structure of this URL was the literal structure of the files and folders on the web server. That's the old-fashioned way to do it. Now, if you go to Amazon.com and you see this page, this is not a file sitting on a server, not at all. This is a dynamic object. It notices who I am because I've logged into Amazon before, and it customizes it. This is connecting to databases containing products. It remembers what I've been buying and wants me to buy it again. It recommends things. Each person that goes here will see a different thing with different prices. It's a whole assortment of complicated applications, choosing what to show me based on what I bought before, who it thinks I am, my zip code, my country, and all that stuff. This is the modern application. It is a completely different structure than the old-fashioned Web 1.0 site like this, where you would just be downloading images and pages from a server, just getting a copy, and everybody that goes to the site will see exactly the same page. That is not the way modern web apps work at all. And all these things, e-commerce, banking, and all that jazz. So the fundamental problem is now it takes input from the user. Now my site doesn't really take any input from the user. You can't log in, you can't buy anything. You can just go to the page and view the page. You can download stuff, but there's no way for you to send anything up, obviously. So there's not much way to hack my page, although people have managed to do it occasionally, but it's not obvious because there's nowhere you get to put in information. But a website like Amazon, you get to log in, you get to type in messages, so you can put in input, and therefore, if you can find input that the server will misunderstand, you can take over the server. So here, like here, Web 1.0 is just a page. You look at the page, nobody logs in or submits contents or anything. Now, in principle, they can still do things. They could hack into the web server itself due to flaws and take it down or steal the files you didn't intend for them to get on the web server, but the hacking opportunities are pretty limited. But a modern web app, you log in, people submit content, and because you're logging in, that means the website has some kind of database storing usernames and passwords, and that's a high-value target to steal. Good evening, Rouhani. So there's more information to steal from it, and it has more avenues for you to steal it because it takes data from the user in many ways. So there's shopping, social networking, banking, gambling, and all this jazz. And all these are Web 2.0, where the user can send data up to the server, and the server has to store that data and often send it off to different users, and all that causes risks, which leads to the modern world of web app hacking. So you got these cloud services like Google and Gmail and all that jazz, Outlook Web Access, and all kinds of other things people are using, where you go to a website and see data that people have put there. And so HTTP is the protocol used to send requests to the server, and see pages. It's designed for Web 1.0 and repurposed in small ways for later versions. So it's lightweight and fast. Yes, I'll add people when I'm done with the first chapter of lecture, Rouhani. I can't add anybody until the first class has gone by. So I'll do it in about a half an hour. All right. Anyway, so your browser runs on many devices by sending HTTP requests to the web and getting responses. And so breaches are now very common. When people do manage to find some kind of weakness in a web server and take it over, then they can steal the data and sometimes take it over completely. One thing that happened recently to a zoo is they took over the site and they added malware to the site, so all the people going there had their payment and login data stolen. That's a common one, to add HTTP JavaScript keyloggers to a page. So you go to a page, they'll tell you it's secure. A bunch of pages will tell you our site is secure. This is usually fake. And if anybody ever tells you any product is 100% secure, you know they're idiots. There's no such thing as 100% secure. And nothing's ever perfect. So there was a blockchain voting system that claimed to be 100% secure, and I complained to them saying you shouldn't say that, and they didn't care. But the fact is they shouldn't say that, because there is nothing at all that's 100% secure. And a study by your textbook authors showed how many tested applications had flaws, and cross-site scripting is the most common flaw. An enormous number of websites have this flaw because they don't take it seriously, although they should. And SQL injection is a much more serious flaw, not as common, but you can steal all the data on a website with SQL injection. We'll be doing that in projects soon. And there's a lot of other flaws like broken authentication or access controls, so the site can be fooled into letting you log into an account even if you don't have the right credentials, or letting you access something that should be restricted even though you haven't logged in first. That one is very common. Insecure direct object access, where there's something you can view where it really ought to make sure you've logged in with a high privilege account before you view that, but the page lets you view it. So here's a request. An unauthenticated request could download personally identifiable information from users on this site, and you get personally identifiable information here, people's username and passwords, which you shouldn't be able to get unless you have first logged in as the administrator. And so in mobile apps, which are very similar to web apps, there's lists of the top 10 risks, various things that can go wrong, like broken cryptography and improper session handling and data leakage and so on. And we're going to study these things and exploit them. And I did a big study of mobile apps a few years ago. I tried all the top banking apps, investment apps, and insurance apps, and found almost all of them had serious vulnerabilities, which I reported, and almost none of the companies cared or did anything about it. Although one of them did, many years later, actually hire me to teach secure coding to their programmers, so that's nice, but they didn't take action as thoroughly or as quickly as I wanted them to, which is the normal situation with security pen tester types. You find flaws, and it's very hard to get management to go to the expense of fixing them. Also found a lot of website security problems at colleges with SQL injection, colleges with malware on the servers that was selling Viagra, and so on. And again, as usual, I told the colleges, but most of them did not patch it and didn't care. So the fundamental problem causing all these vulnerabilities is users can send in arbitrary input. You've got parameters, which are like fields you fill in on a form, like your name and address and the product you're buying. And cookies is another bit of data sent with requests, headers, and developers don't understand this. They are not taught security. Most web developers, and for that matter app developers, don't think about security, and they're not taught security. They get good grades, they go through textbooks, they learn how to code, and they're writing insecure code. This is a fundamental problem with our industry. It does mean that all of us in security have job security, because every company has to hire developers to make their product, and then they have to fire a security team to fix the holes in their product that developers put in there for not knowing security. It's kind of crazy, but that's the way it is. So one thing developers typically assume is they assume that their code will run as they wrote it. They don't really understand what portion of their code is on the server and what portion of their code is in the user's browser. And of course, the code that runs in the user's browser cannot be trusted. A user can turn off JavaScript in their browser, and also you can use attack tools like Burp, which let you modify what's coming out of your browser so you can change things. Even if the developer didn't give you a button to click on the page to change something, you can change it anyway. So really any data that comes from the browser should not be trusted. But developers are typically not having that security mindset. They're just trying to make the page work. When normal users come in as intended, they aren't saying, well, what if the user was an evil hacker deliberately trying to trick my server and sent in nasty input full of like special punctuation marks or something? They have to always think about that, and a lot of them are not thinking about that. So you might be able to change the price of an item, get into another user's account, or use SQL injection, which will do a lot, which lets you steal data from a database. And it's just the thing called Secure Sockets Library, or TLS these days, which puts a padlock up in your browser, encrypts the data, but it doesn't stop any of these attacks. It's called HTTPS for secure, and it is secure, but the only security guarantee is that you know which server you're talking to, and nobody else can receive the data except that server. But a whole bunch of web attacks will work over HTTPS because they involve sending data to the server, which is then misunderstood at the server and has an effect which violates the security policy on the server. So even though it has the word secure in it, secure HTTPS, does not mean that you're secure against all attacks. It just stops a certain category of attacks that involve intercepting traffic and modifying it on the fly. So, like I said, the fundamental problem is the developers are not aware of security or trained in it enough, and they'll write custom things, and it's easy to make a website, but it's hard to secure it because it usually takes a different person with a different mindset to think about it. One conference I went to separated people into breakers and builders, and that seemed like a pretty good way to look at it. Some people just look for the flaws in things. That's where their mind goes. I'm one of them. I mean, when I read articles, I'm always mad at the typographical errors and the grammatical mistakes. I was just listening to Michelle Obama's speech, which everybody loved, but the first thing I heard her say was Harris is the most qualified person ever to run for president. And I immediately stopped and said, that's not true. Joe Biden was far more qualified. Mitch Romney was far more qualified. I can think of a bunch of people that were more qualified, and that bothered me. And everybody else just let that sail through and went to her later points that were much better. But, as soon as I see one flaw, I focus on that flaw. That's what bothers me, even if there's a whole bunch of other things that normal people would worry about. And that's a breaker mindset. You look for flaws. Anyway, so we had edge defenses like a firewall protecting a whole network, and then inside the network we'd have what was called a trusted zone. That was Microsoft's recommendation for security up until 2002. But now we don't have a reasonable perimeter anymore. People have mobile devices, and you can't really define a barrier and say inside here it's secure and outside there it's insecure. Now what we have to do is think about this in another way. Every time any system makes a request to another system, you should inspect it to see if it's suspicious before trusting it. And that's the model the U.S. government now recommends, called zero trust. We're all moving gradually in that direction. It's very difficult to set up. It's a lengthy process to get there. There is a product called Zscaler I have heard about, which will do this for you, where all of your network devices, instead of connecting them to your own firewalls and switches and stuff, they all log into the cloud service, Zscaler, and now it will examine all the requests for network requests and filter them out and see if they're malicious. But it's very expensive, and I don't think there's a free version for us to play with, so I only know the general description of Zscaler, but people say it does implement zero trust, and therefore it will help protect you from ransomware. Because to protect you from ransomware, one person gets infected by clicking on a link or running an app or downloading something, and then their machine starts trying to encrypt everything it can reach. And on a normal network, you can reach a file share, you can reach another server, you can encrypt all those files. But if you had good protection, like apparently what Zscaler offers, then when your machine tries to make a bunch of requests to change thousands of files on the server, it will notice that looks suspicious, that doesn't look like legitimate activity, and block it. And that would be good, but almost nobody has it because it's too expensive. So anyway, so vulnerabilities are getting better with time, but there's still a lot of vulnerabilities, and a lot of people get hacked on the web, and that's why we're here. There's a rich market to hire security professionals to find flaws and patch them, and here we're mostly interested in finding them. So let's try a Kahoot. You do not have to do this, but it's usually popular with the students because it sort of breaks up the class and makes it more fun. We play a little game here, and you can get extra credit if you're in the top 3 performers at the Kahoot. So there you go. So go to kahoot.it and type in that number and pick a name. You can use your real name or a fake name. But if you use a fake name and you win, you will have to tell me who you are for me to give you your points. Although I do keep a record, so if you keep using the same fake name, I remember who's using that fake name. Like Tark, I know who Tark is. I know who Zen Hacker is too. But I don't know who AM Beer Hacker is or most of the others, so if you win, tell me who you are if you want your points. And there are sometimes people who wander in who are not really college students and don't really care about the points, and that's fine too. We do the best we can to give you points. That's what I thought. Usually takes longer than this for people to get in the first time. I'll wait a little bit longer. And if you don't know how to get in, note up here, go to kahoot.it. People ask me this question frequently, so maybe that'll help. All right. It's Italian, I guess. I think that's what the IT is. All right. Oh, people still coming in. Okay. I'll wait a bit more. All right. All right, so what makes Web 2 different than the early web? Yeah, that's the main thing. Web 1 was like television. You just watch it. You can't send anything up. It's view only. But Web 2, you can send up things like Facebook posts and tweets and all that jazz. All right, what does SSL stop? Yeah, this is what it stops. Man-in-the-middle attacks, the more modern term being adversary in the middle, and data modification. Somebody intercepting your traffic, like on a wireless network, can't read it with SSL because it's encrypted and they can't modify it. This is the attack it stops, but it doesn't stop any of these attacks, which involve sending data to the server, which is misunderstood at the other end. All right, what's the most common website vulnerability? Cross-site scripting is by far the most common, more common than any of these others, and is less dangerous than these others, but it's still dangerous. What's the most important defense method? This is actually an interesting one. Most non-technical people will say antivirus because they really believe their antivirus is protecting them. The experts know your antivirus is not at all as strong as you think it is, and your real most important defense is updates. But anyway, it's an interesting issue, and updates are generally regarded as the most secure, the most important thing to do. Keeping your stuff up to date is, although all the rest of these are good things too, but keeping things up to date is probably the single most important security measure you can have. All right. Although, to be fair, for home users, the most important security measure is to use a password manager so you quit using the same password on every website. That's, all right. But it wasn't on that list. All right. All right, so I imagine RS is initials. That might be enough to uniquely identify you. I'm not sure.